Hello students, welcome to another Grandmaster video. Today I'm going to explain you the answers of multiple choice questions of Edexcel IAL Physics 2019 May new specification paper. Let's move on to the first question. First question states that which of the following is an SI unit for electromotive force or EMF? We have four answers: Coulomb, which is the unit of electrical charge; Joule, which is the unit of energy or work done; and Newton, which is the unit of force or weight. And the final answer is volt, which is the correct answer, and this is the unit of potential difference and EMF or electromotive force. In this examination, you may also get some questions including these units: watt, which is the unit of power; Pascal, which is the unit of pressure. Remember, all these units and quantities are derived units and derived quantities. Let's move on to the second question. A filament lamp is a source of unpolarized light. A polarizing filter is placed between a filament lamp and an observer. The filter is rotated in the plane perpendicular to the direction of travel of the light. Which of the following is observed as the filter is rotated through an angle of 90 degrees? First of all, you have to understand what a polarizing light or what is meant by a polarizing or polarized light, or what do you mean by an unpolarized light? An unpolarized light is a light beam which has many planes of oscillations. Usually we denote an unpolarized light using this diagram. And a polarized light is denoted using this diagram. What do you mean by a polarized light? A light beam with a single plane of oscillation is called a polarized light. So according to this question, a filament lamp emits unpolarized light. Now, if you send this unpolarized light through a Polaroid, you will receive a polarized light. Now, what will happen if you rotate this Polaroid by 90 degrees? Then you will get a polarized light where its plane is in the horizontal direction. In the previous diagram, plane of the oscillation of the polarized light is vertical. So does it change the intensity of the light, or does it change the orientation of the plane of oscillation of light? According to this, you can observe what happens is the plane of oscillation is also turned, is also rotated. So the correct answer for this question should be that the light intensity does not change, or answer C. Let's look at the other answers. The light intensity changes from maximum to minimum, answer A. And answer B states that light intensity changes from minimum to maximum. And answer D states that light intensity is zero throughout the rotation. So why they have given this question? This question is given to confuse the students, because you have learned in the experiment to determine the sugar concentration of a solution, you have learned about polarized light. But remember, in that experiment there are two Polaroids. This is the first Polaroid and this is the second Polaroid. First Polaroid polarizes the unpolarized light beam. When this polarized light passes through the second Polaroid, if the slit of the second Polaroid is parallel to the plane of oscillation of the polarized light, the light will be transmitted through the second Polaroid. But if the slit of the second Polaroid is perpendicular to the plane of oscillation of the polarized light, no light will be transmitted through the second Polaroid. So if you rotate the second Polaroid from the parallel orientation to the perpendicular orientation, you can observe a change in light intensity. You can observe a change in transmitted light intensity. This phenomenon is used to determine the concentration of sugar solutions in your experiments. Let's move on to third question. When a guitar string is plucked, a sound of constant frequency is heard. The wave produced on the vibrating guitar is. We have four answers and the correct answer is answer D. It is transverse and stationary. First, let's find out what is a transverse wave and what is a longitudinal wave. A transverse wave is a wave where the particles in the medium vibrates or oscillates in a perpendicular direction to the direction of wave propagation. A longitudinal wave is a wave where the particles in the medium vibrates in a parallel direction to the direction of wave propagation. If you look at this diagram, it represents a stretched string between two boundaries. When you plug this string, a wave is produced, and this wave is a stationary wave or a standing wave. The reason is the energy of the wave is trapped between these two boundaries, and you can observe the particles of the string vibrates up and down vertically, which is in a perpendicular direction to the direction of wave propagation. Therefore, a wave produced on a stretched string, is a stationary wave, and it is also transverse. Let's move on to fourth question. Which of the following has the largest de Broglie wavelength? In order to answer this question, you should remember the de Broglie equation. De Broglie equation states that lambda equals h over p. Where lambda is the de Broglie wavelength, h is the Planck constant, and p is the momentum of the particle. Momentum of the particle is given by mass into velocity. And according to this question, it asks us which of the following has the largest de Broglie wavelength. So h, or Planck's constant, is a constant. In order to have a larger wavelength, the momentum of the particle should be minimum, or product of mass and velocity of the velocity of the particle should be a minimum. In this question, we have two particles, an electron and a neutron. Out of these two particles, electron has the least mass, and therefore answer A must be the correct answer, since that electron is traveling at a lower velocity, which is 3 into 10 to the power 5 meters per second. So this question can be answered easily without any calculation if you remember this relationship. Let's move on to fifth question. Which of the following graphs show how current I varies with potential difference capital V for a negative temperature coefficient thermistor? First of all, you should understand how the resistance of a thermistor varies with temperature. Resistance or resistivity of a negative temperature coefficient thermistor decreases with increasing temperature. That's why it is called a negative temperature coefficient thermistor. Then you have to remember the relationship between potential difference and current, which is given by Ohm's law. According to this relationship, resistance is defined as potential difference per unit current. And in the answer graphs, they have given us the graphs of current versus potential difference. Gradient of this graph must produce I over V. Which is the 1 over R. So, in a negative temperature coefficient thermistor, resistance decreases with temperature. So, in any component, as you increase the current or potential difference, more heat is generated. Therefore, temperature is increased. Due to the increase of this temperature, resistance of the thermistor should decrease. So as the resistance of the thermistor decreases, gradient of I versus V graph should increase. According to this explanation, our correct answer for this question should be answer C. If you look at the other answers, answer A is the IV graph that is used to represent a fixed resistor, and answer B is correspondent to a filament lamp. Let's move on to question 6. A string is stretched between two fixed points and set into oscillation. The frequency of the vibrating string is not dependent on. The question is, frequency of the vibrating string is not dependent on. In order to answer this question, you should remember the formula or the relationship between vibrating frequency and the tension of a stretched string. And tension and mu of a stretched string is given by this formula. Here T is the tension, mu is the mass per unit length, and L is the length of the string. So you can see the frequency depends on all these three quantities. Therefore, the only answer for our sixth question is the amplitude of the string's vibration. Let's move on to seventh question. An ultrasound transducer is placed on the surface of a solid object as shown. A pulse of ultrasound is transmitted into the object. The pulse is received at the transducer 50 microseconds after it is emitted. Which of the following can be used to calculate the speed of sound in this object? This is a very simple question where we have to use the relationship of speed equals distance over time. If we consider the time taken, total time taken for the sound wave to travel back and forth, forward and backward is 50 microseconds. Then if you consider the half of the journey, the time taken would be 25 microseconds, and the distance it traveled within this time would be 10 centimeters. Therefore, we can simply find the answer You should be careful when calculating the answer. The distance is given in centimeters, but you should convert it into meters. And time is given in microseconds, you should convert it to seconds. So the correct answer for this question should be answer B. Let's move on to 8th question. Two copper wires of identical cross-sectional area are placed in series in a circuit. Which of the following could be different for the two wires? Let's consider about the answers. Answer A, charge carrier density. Since both the wires are made of same material, copper, their charge carrier density, or denoted by simple N, must be the same. Therefore, answer A is not the correct answer. Answer B, current. Since the two wires are connected in series, current through both the wires must be same. Therefore, answer B is also not the correct answer. Answer C is drift velocity. In order to determine this answer, you should remember the transport equation, which is given by here. Vd is the drift velocity of the charged particles or electrons, I is the current, N is charge carrier density, A cross-sectional area, and E is the charge of the charged particle or the electron in this case. According to the question, we saw that current through both wires is the same, charge carrier density is same, and they have same cross-sectional area. Also, the charge of electrons remains the same. Therefore, drift velocity of the electrons through each of the wire must also be the same. The only difference quantity is potential difference. The reason is, in the question they have not mentioned the length of the wires. They might be different. If the lengths of the wires are different, they would have different resistance according to R equals rho L over A. Since they have different resistances, they will have different potential differences across the two wires. So the correct answer must be answer D. Let's move on to question 9. The definitions for current and potential difference both include answer for this question is answer A, or charge. Let's find out the definitions of electric current and potential difference. Electric current through a conductor is defined as rate of flow of charge. In other words, I equals Q over T. Definition of potential difference is given as work done per unit charge. Therefore, the quantity which includes in both the definitions is charge. Let's move on to 10th question and the last question. The diagram shows how the displacement varies with distance along a stationary wave at 2 instants of time. Which of the following statement is not correct? Points X and Z are antiphase with each other. This answer is not wrong. The reason is, on a straight string, if you consider about points on either side of a node, then they are in antiphase. You can see in this diagram, X and Y are on either side of a node, therefore they must be in antiphase. If you look at answer C, point Y and Z have the same frequency of vibration. So that statement is also correct, since Y and Z are within the same loop. And point Z is an anti-node, that is answer D. That statement is also correct since Z has the maximum amplitude. Therefore, it is an antinode. So the correct answer for this question should be points Y and Z have the same amplitude of vibration. Also, even from the diagram, you can observe that they have different amplitudes. And that's the end of the answer explanation of MCQ questions for 2019 May Edexcel IAL Physics Unit 2 paper. If you want me to explain the answers for any specific structure questions, please comment below. I'll make sure to answer as soon as possible. And don't forget to like, comment and share our videos. Also make sure to subscribe our channel so that you don't miss any of our future videos. And click the link here or somewhere that I'll put in this video at the end of the video if you wish to watch Edexcel IAL Unit 2 revision video. See you next time with another enjoyable scientific learning experience.